I'm a contractor, consultant, have been for many years now. I do Java, Scala, PHP mostly, and based out of the Netherlands. Do a lot of interesting projects there. My speech topic is about continuous deployment and how we introduced that in a large Dutch company in 2015, so 2 years ago, almost 2 years ago, and how they transitioned from old school waterfall to agile and implemented continuous deployment as well during that. All right, welcome everybody. Big full room. Thank you all for coming. As I, on the little interview said, today I will be talking about continuous deployment and how continuous deployment was implemented at a large Dutch company over a period of about a year. My talk will take about 40 minutes, so you'll understand if I have to compress a little bit of what happened into this talk. The things I'll be talking about may or may not work on your own projects. They did work mostly on the project I'll be talking about. The talk does contain some Java code examples, but that can be translated into pretty every language that there is. So they're pretty much agnostic. Okay, a little bit about me before we get going. As I said in the video, I'm a contractor and consultant, speaker and a trainer, coach from the Netherlands. I've been doing some interesting projects in the past few years. I'm part of a company called 4Scouts, and we have a label, make.io, where we do continuous deployment, continuous delivery consultancy. If you want to reach me during this talk, well, I won't be reading it, but after the talk maybe, then that's my Twitter handle. Okay, let's get going. This is a story about a company in Amsterdam, in the Netherlands. Specifically in the north of Amsterdam, next to the beautiful river at IJ. And this company is called Persgroep Employment Solutions, which is part of the Persgroep, which is a large Belgian and Dutch conglomerate that has a bunch of big newspapers and other media sites. They also have a number of job sites, so sites, job boards, where companies would place jobs that are available, and then potential employees would search for a new job or a better job on those sites. As I said, this was in mostly 2015. I started in the end of 2014. I was there for about a year with a bunch of external consultants that were brought in to transform this company because there were a few things going on. And what was going on was there was a system, an old system that was effectively a large and aging monolithic application. That large and aging monolithic application was the result of a number of takeovers and mergers between other companies and a relatively messy code base as a result. However, it does generate a lot of income. It's a successful company, so the system, even though it is large and aging, generates actual money. But at the same time, it's very slow. Page loads up to 5 or 6 seconds were not unheard of. Very complicated to maintain, to manage, and a bunch of technical debt as well. Now, if we put it all in a graph, the system, the overview of the system looks a little like this. In the top, we have the 3 labels, the 3 job sites effectively, and they all come into the system through a bunch of load balancers and varnish caches and other things. And then all the 3 sites are handled by a stack of front-end servers, which in turn connect to a stack of back-end servers. Now, on those 2 types of servers, the exact same code runs. The only way to distinguish between the 2 is a flag. Am I front-end or am I back-end? But they run the exact same code repository. They talk to each other through a number of ways, RESTful, RPC, direct database connections, no real homogeneous solution. And then in the bottom of the picture, they talk to FTP, external services, Solar, databases, stuff like that. So lots of moving parts. And the team that was dealing with all these moving parts, a 16-man team before we got on board, that was becoming very careful maintaining this system. They did manual releases every 4 to 5 weeks, generally downtime and generally during the weekend. And the problem with a job board is that people looking for jobs generally look for them at night and in the weekend. So people looking for jobs were unable to do that during release periods. That was a choice because the people that actually paid the site, employers, recruiters, usually use the site from 9 to 5 on a weekday. But the manual release was a problem for some of the users. Fragile tests, a lot of them, and they fell over for no apparent reason. And then the next build day would work again. So very untrustworthy. A lot of issues, a lot of outages after releases, but also from day to day. A lot of bugs in the system. And the team, as a result, was becoming pretty frustrated, had low velocity. Simple features could take up to 2 or 3 months to deliver. And the business was essentially starting to find this very unacceptable. So a few goals were set. And the first goal is reduce all the number of issues, reduce the outages, the bugs, all the problems that were associated with the existing system. Another goal, reducing the lead time. And by lead time, I mean the time it takes for an idea to make it into production. So when I start thinking about a story, start thinking about functionality, up until the very moment that a consumer is actually able to use that functionality. And like I said, that could easily take 3 or 4 months, and sometimes even worse. And with a competitive market such as job boards, that's simply not acceptable anymore, at least not in this day and age. Third goal, increase the productivity of the team. Make them able again to deliver value rather than firefighting and coping with issues. And last but not least, but a very important one, increasing motivation of the team. There's a lot of interesting developer jobs on the market in the Netherlands, and you want to retain that personnel. So you want to give them something to work on, right? Something interesting to work on. So those were the 4 goals. Now with those 4 goals in mind, we can ask a few questions. And the question that was asked, do we refactor? Do we rebuild? And refactoring, well, the first problem is, where do you begin with such a big system? Whatever you pull out, you pull more and more and more, like the ball of yarn. But even then, the team started doing that very enthusiastically, and after 3 months, they had a code coverage of 2.5%. So in 10 or 15 years, we might be at a reasonable number. But that obviously wouldn't fly, right? So a rebuild was considered, and with rebuild, we considered what we call the cut-over rewrite. So we build a second system next to the legacy system, and we build it and we build it until it reaches the same level of functionality as the old system, and then we flip a big switch. That never goes wrong, right? So, and the problem with a cut-over rewrite is that you rebuild all the same bugs that have become features over time in the system because they have been around for so long. And over time, the reasons behind why things were implemented are lost. People have left the company, decisions were never recorded, all those things. So a cut-over rewrite is not going to help us here. What is going to help us is the approach we took. We said everything needs to be an API. API first, consume your own dog food. There were APIs used by external companies to look for jobs and inject jobs into the system. We need to use those APIs internally as well. Otherwise, they will always be second-class citizens, right? So we use our external APIs internally as well. We also said that we want to go to a service-oriented architecture where we group our services roughly around domain objects such as a job or job seeker. So they may not strictly be microservices, but they are services. And what we also stated was that we are going to migrate individual pages. Remember, this is a web app, so we can migrate individual URLs from the old system to the new system. And on the right is a bunch of the tools and the languages and the stack that we used. Now, when I say migrating individual pages, how would we go about doing that? That's something called the Strangler Pattern. The Strangler Pattern starts on the left with the original monolith, getting traffic from the internet, connecting to a database, right? Pretty standard. And then what we do is we start adding a proxy between the user and the monolith. Initially, the proxy doesn't do anything but pass the traffic. But then we start adding a service with its own database potentially, and we implement some functionality in that service. And then we add a rule in the proxy that we move or we let the traffic for that specific URL flow to the service. And the monolith is still doing all the rest, right? And then we start adding more services until at some point we are at a point where we think, okay, now we've built enough functionality that we can switch off the monolith and throw it away. That's the point of the Strangler Pattern. It's like the tree, like a parasite plant that grows on a host and effectively kills it, which is roughly what you want to do with the monolith, at least in this case. The proxy looks a little something like this. This is Apache 2 code. And in this example, we would route everything on, say, an internal network, a specific IP address range, and a specific URL to our new service. And everything else goes to the monolith. And when we build new functionality, we don't build it in the old application, but only in the new series of services. And then we add rules and rules and rules until effectively the monolith is not doing anything. So in terms of architecture, we said that every front end is a service on its own. It's no better, no worse than a backend service. It exposes an API. You can connect to it using a browser or even curl if you want, but it is a service all the same. Every service, so front ends as well, is behind a load balancer, which allows us to scale up or scale down at will, but also replace services and upgrade them so we don't have downtime. Some of the services, unfortunately, need to be able to access the legacy databases to clean up the data model. No way around that, at least not in this project. And last but not least, we went for containers. Docker at that point, every service in its own container. And then the picture starts looking like this. We still have the three labels, the three brands at the top, but now they are served by their own individual front end, enabling us to innovate on that individual front end. They call services and they use their own databases and search and stuff like that. And on the left, we have our legacy application, which runs on-premise, effectively boxed in. All the new things run on AWS in the cloud. Okay, so now I stated architecture and approach. Let's take a look at how what we set down in terms of process together with the team. We try to be in production as soon as possible, ideally after the first sprint or during the first sprint. And what we also said is everything we do it on a continuous life cycle. And continuous everything basically means that we iterate. We don't do projects, we do small steps, experiments, and improve from day to day to day, right? You heard me say continuous deployment a few times. There is some discussion about what continuous deployment means. You've probably also heard the term continuous delivery. They have a subtle difference, and I'll explain my view on those terms. It all starts with continuous integration. That's been around for a while. And continuous integration basically says we have a developer on the left, and they check in some code, and then a process starts running to build and test that code. Now, depending on the language you're in, building may be compiling for Java or .NET, but for JavaScript it may be packing, Webpack or something. But after you build, you end up with one single artifact that is deployable in some way. And you also run the tests, of course. Now, if that is all green, all the tests pass and the build completes, you have that one artifact, and that's where CI stops. Now, continuous delivery adds two more steps. The artifact that you build and test is automatically deployed to an acceptance environment, where we can then test and click and try and UAT to our heart's content. And at some point, someone is going to say, okay, this is good enough to go to production. And then we push a button. And the deployment to production should be automated, so it should be a script or something, but the actual trigger is going to be a human, hence the red arrow. So a human is still in control there. Now, if that's been going well for a while, there's no need to have that human involvement anymore. That's where you end up with continuous deployment. Continuous deployment is automation from start to finish. As soon as your deployment to acceptance, which at this point loses its meaning a little bit because there's nothing to accept, so I tend to call it staging or pre-production, but let's call it acceptance, or it doesn't really matter. As long as the deployment succeeds in that environment, we automatically go to production. So we continue. My personal view is that this whole pipeline should take no more than 20, possibly 30 minutes from start to finish. I know there are people around that find longer build times acceptable, but personally I try to get it down to 10 to 15 minutes. And I'll explain why in a little bit. Now, continuous deployment is somewhat contentious. Why would we want continuous deployment? Well, one of the very important things is that it allows you to do small steps. A lot of releases, maybe multiple times per day, and those releases are effectively then very small, right? There's not a lot that you can do in a few hours. So small steps, very important. Early feedback, that's what comes from small steps and a fast pipeline. If you deploy to production in under 30 minutes, you have very fast feedback of when what your change is going to do. If you have to wait for 3 weeks to get it in production, you don't have fast feedback. If your pipeline takes 20 minutes to deploy, the time to recover is a lot less as well. And last but not least, it allows you to do experiments. Experiments on the level of, let's move that button to the left and see what it does. And that is deployed to production after 20 minutes, and we can immediately see and verify that change. Rather than having to wait for it for 3 or 4 weeks, plus in those 3 or 4 weeks, a lot of different changes were added as well. So we may not even be able to see whether our change is uniquely responsible for making things better or worse. Now, research has shown that successful teams do 200 times more deployment than less successful teams. They recover from failures 24 times faster, their change failure rate is 3 times lower, and their lead time is a whopping 2,500 times shorter. So going from 3 months to maybe a few days. When you do continuous deployment, and when you do a lot of small releases during the day, we state that every commit goes to production. Every commit goes to production, and that could mean that it is grouped in 2 or 3 commits, depending on the timing, if you commit very close together, and it may be 2 or 3 commits. But in general, every commit is built and tested, and if everything passes, deployed to production. If you do it at this speed, I personally believe very strongly that there's only one thing to do when it comes to branching, and it's that we only commit to master. And with master, you can read trunk, or whatever it's called in your versioning system, but it should be one main line of development, which means no branches, ever. Yeah, pitchforks, mob. This is what happens, or this is one of the things that happens with feature branches that stay around for a long time. And this is only one of the things. Feature branches or branching in general is, if I say it very black and white, is abusing your version control for functional separation. And by functional separation, I mean the timing of features to go to production. That's usually what we use feature branches for, which is, by the way, the wrong use, but it is used for that. Feature branches delay integration. CI, continuous integration, states that we should merge with the main line of development at least once a day. If you have a feature branch that's older than a day, you're already violating that principle. And by feature branches, especially if you have a number of developers on the same project, you increase the distance between those developers, technically. And you increase the chances, let's assume you are able to fix the merge conflicts, but you're never going to test whether functionally, whether two features work on a functional level together. Plus, merge conflicts lead to all sorts of interesting scenarios as well. I also strongly believe that pull requests are out of the question as well, because pull requests are branches, and depending on how fast somebody reacts to a PR, that may turn into a long-lived branch. But then people say, okay, Michiel, that's all fine and nice, but we do pull requests to do code reviews, so how would we do that? Well, there's one simple answer: pair programming. Maybe not like this, that's not totally effective, but pair programming is the answer, because a pull request, review through a pull request, is an asynchronous pull request or code review. Pair programming is a continuous inline code review. Rather than having one person do the developing and then another person doing the reviewing after, you put those people together and make them work together, and the end of it all is that they give a much better result, right? So pair programming, don't enforce, but encourage. People will learn soon enough, at least on this team, that it's useful. It improves the quality of your code, it improves your confidence. And we try to mix and match experience, so less experienced with more experienced. In the project, we focus on value, repairing the rift between business and development, and delivering stuff again, delivering new value. It also means that new features are not built in the old code, only in the new system. Now, I talked about feature branches and functional separation. The real answer to functional separation is a feature toggle. A feature toggle allows you to decouple a deployment, which is a purely technical exercise to me, from a release, which is a business decision. With a feature toggle, you can deploy to production continuously and still have a feature invisible for an end user until it is ready. But it is completely tested. It's part of your unit tests, etc. It also allows you to do inline A/B testing. On the left, we have a search page. On the right, we have another, the new version. With a feature toggle, you could say, half of the people on the site get to see the new version. And we find out whether they respond better or worse. If they respond better, then we improve or increase the amount of traffic. Another rule, the Boy Scout rule: leave your campsite in a better state than you found it. So improve your code as much as you can within reason. If it takes more than an hour or say, you may need to discuss with the team. But if it's small things, do it. Because otherwise you would end up with broken windows. And one broken window leads to another, leads to another, leads to people not caring anymore. Broken window syndrome. Quality. Quality is essential. It's a precondition for speed. And we have a few quality gates in this project. One of them is technical debt, duplicated lines of code. They are soft quality gates, so they don't fail the build. But one that does fail the build is the code coverage requirement, which is 100% in this project. It's only for new code, so we can enforce that. It means that if you fail the build because you go to 99.9, you get to have a discussion, a conscious discussion, whether the code you checked in, maybe some stub code or something else, could be ignored for this specific case. But if you set 80%, for example, you don't get that discussion as long as you stay around the 80% mark. Now, the asterisk says that I personally believe this is as very useful for in languages that don't have a compiler, because a compiler is another step in the safety net. And if you don't have a compiler, you run the risk of deleting code that's still used, right? We're all here on a DevOps conference, and DevOps, I've been doing DevOps without consciously knowing it for years, because I like to do things. I like to get things going. DevOps at this point is starting to become somewhat of a container phrase, and people start adding things to it. But to me, DevOps is at least creating a team where developers and operational people and everybody that's involved with the product together so that this doesn't happen anymore. We want to make a team responsible for keeping a product in production. Putting something in production is easy. Keeping something in production is hard, and that's what you need a team for. You also need monitoring. If it moves, graph it. If it works, measure it, and then graph it. Dashboards. If you find a spare TV somewhere in your office, put a dashboard on it. CPU graphs, disk graphs, log files, everything. Now, one of the most important parts in this project was what we call the build pipeline. The build pipeline is what gets our code from start to finish and deploys it into production. Our build pipeline is automated as much as possible. Repeatable things, building, testing, deploying, configuring, orchestrating, all those things. Because if we leave that to humans, you see variation. Humans do the same task differently from day to day because they haven't had enough sleep, worry about home, whatever is going on, there's variation, which a script is not bothered by. The build pipeline allows us to do continuous testing, part of the continuous lifecycle. We defend in depth. We defend with unit tests. Unit tests allow us to test a very small piece of code, a small system under test, where we mock the rest of the world around it. Then we move on to integration tests, where we might test against an actual database or a fixture data that we have under control. We might be testing against an embedded Elasticsearch, what have you. Acceptance test then is where we talk about functionality, about acceptance criteria, about interesting things in normal English. So not about implementation, but about intent. Are we building the right thing? And then last but not least, UI tests, where we use Selenium, Protractor, and all those tools to test our UI, to click on things and see whether they still work. And then the tester amongst us would surely ask, but what is my role going to be? Everything is automated. I don't have time to click on things between the deploy to staging and the deploy to production. So what's my role going to be? Well, the tester is more important than ever. They are part of the three amigos, a group of a developer, a business expert, and a testing expert. At least three people, at least a Chevy. And they are uniquely qualified or uniquely set up to make the best possible version of a story they can come up with. Very important. Now, the continuous testing leads to something called the continuous testing pyramid, where on the bottom you have the unit tests, and at the top you have a smoke test, which is essentially a health check. In the pyramid, you see that the cost goes up as you go up, so it becomes more expensive, and the speed goes up as you go down. So it becomes faster. So unit tests are the cheapest and the fastest. Smoke tests are the slowest and the most expensive because they require a running system. You also see monitoring, as I mentioned before, and exploratory testing, where a tester would still, from time to time, go through the system and actually verify that things are still working. The critical paths. Right, starting to wrap up, pipeline as code. Very important concept in Jenkins, one of the tools we used in this project, where we, as code, state how our pipeline works. In stages, sequential stages. We build, or we run the tests, we build a Docker image, and then we deploy to staging, and then to production. If one of the stages were to fail, the entire build is failed. The entire build is red. Now deploying, I'll tell you how we deployed in this project. It's only one way of deploying. There are numerous other ways, but this is the strategy we used. It's called the rolling update. And using Docker, we first pulled an image, and then we started a new container based on that image. Wait for it to come up on a port. It's a service after all. And then we do a health check. If you use Spring Boot, for example, you get an automatic health check on /health, and you can check against that. If that's all okay, we add it to our load balancer, starts to receive traffic. And then we remove one of the old containers from the previous build, from the load balancer. And then we stop and remove that container. We repeat this until all the old containers are gone, one by one. And if something were to fail, for example, in a health check, we stop. And we still have the old containers serving traffic, so there's nothing wrong. Typically, it would fail on the first deploy right there. And when you view that in Jenkins, it looks a little something like this. The stages sequentially aligned, and if one of the stages were to fail, it would color red, and all the other stages for that build would not be executed. If that happens, you want feedback. The Siren of Shame. It's a literal siren, an LED lamp with an audio signal attached to it that triggers the team to respect and fix the build as soon as possible. Because if the pipeline is the only thing you have going, that's your lifeline, right? It's very important to fix it as soon as it breaks. Okay, wrapping up, let's take a look at some of the results of this project. The average build time per service was under 10 minutes from start to finish. We averaged 50 plus deploys per day over all the services we had. We significantly reduced the number of issues and outages and firefighting. And we improved the page load times by a fair margin, from 5 to 6 seconds down to under half a second. We also improved metrics, also by being faster, like CEO ranking and how many people would be on the site for how long. People on the team got to learn a lot of new technology and a lot of new strategies and way of working. And in general, that increased their confidence. The velocity of the team went up massively, and they had a lot more fun. Now, there were, of course, a few things that we learned. Team acceptance is a key problem, or is a key thing, especially if you have a number of people that have been working at a company for a while, for a number of years. They tend to be a little bit more set in their ways, and it's hard to pull them out of that. But we showed that this works, but it requires persistence. It also requires a motivated team. Luckily, they were motivated because they wanted to do something about the situation. New technology is a plus, but also a weak point. It means that not everybody is comfortable at the beginning with all the new technology. But remember, pair programming, we did that a lot to transfer all the knowledge about the new technology. I mentioned Docker. When we did this, Docker was at 0.6 or 0.7, I think, so there were a lot of stability issues still. We worked around a number of them, and we were kind of betting on Docker moving fast enough that those things would be fixed sort of quickly, but we still had a few issues. We also had a few issues with pipeline stability from time to time, such as NPM failures or other things we didn't always have under control. But that's a very important part as well. I talked about feature toggles. Feature toggles, it's important to keep a cap on them. It's important that if you have a feature toggle set to 100%, you remove the toggle, because the toggle is depth, is technical depth as well. And so we try to maintain a cap, so either the feature goes live, or we remove all the code associated with that feature. That was kind of the point we tried to make to the business. Business alignment is also very important. If you start moving as fast as this team was, 50 plus deploys per day, the business better keep up, which is an interesting problem to have, by the way, but you need to align on that. And last but not least, the legacy monolith is unfortunately still in production right now, about 20% of it, I think. But to me, that shows that there wasn't enough focus on replacing that legacy. And the team still has to maintain that, so they still have a maintenance burden. Okay, if you want to read more about some of the topics that I discussed, Continuous Delivery, the book, the Bible, I should say, by Jez Humble and Dave Farley. Building Microservices by Sam Newman. And on the right, Build Quality In by Steve Smith and Matt Skelton, which is very interesting view of about 20 projects where they pretty much did the same thing. And if you want to hear more arguments about why feature branches aren't a problem, go to trunkbaseddevelopment.com. So the inevitable vendor slide, I'm part of Make.io, as I said. We help companies move faster and make things by advising them on continuous deployment and stacks, things like Kubernetes, all of that. If you're interested in that, I'll be here all day. Come find me. Thank you so much for joining today. If you want to reach me, that's my Twitter handle, my email address, and I also blog about these topics a little bit. So I would love some feedback on that. Like I said, I'll be here all day. So if you do have questions after this session, find me and we'll talk. Thank you so much. Do we have time for questions? One or two?
Yes, we have. Can you hear me? Great. Thank you for the first part. And now we're moving to questions and answers. And I see lots of you here. So can people who have questions raise their hands that I know how to communicate with the mic? No questions.
I'm sure there are a few.
Okay, so let's start here.
Hi, just a quick question on your team size regarding pair programming.
Yeah.
Like, how big is the team? How do you structure this?
We had 16 people people that were working at that company, and then 5 or 6 external consultants like myself. Of the 16, I think 12 or 13 were developers, and then we had some testers and an analyst or so. And they were roughly divided in 2 Scrum teams. And then pair programming as much as possible, and rotating the pairs as well. So having people pair up with different people from time to time. Does that answer the question?
Yeah, so you have pair on top of pairs. So do you do pull requests amongst the pairs? Or like you said you don't do pull requests. So how do you manage that?
The pair commits to master.
Always.
Always. And the commit goes to production if the build passes. Yes. So we release from trunk, we release from master. One there and one there, and they're in the back as well, I think.
Hi, thank you for the talk. Quick question. When moving from monolith to essentially microservices architecture, that team of 16 people, was it divided, and if it was divided, how it was divided on managing a multitude of services?
There was, at the time, there was a sort of a split between front end and back end. So the front ends are services as well, but they would manage the front end services, and 3 or 4 back end services would be with the other team. That was tried, I think, for half a year. We found out that because it's easier to align along product lines. So by now, I think they have teams formed along the brands, 3 brands, and then yes, they have some shared vision on services. But I think service is part of one team, and then the other teams ask the team for improvements to that service. I think that's the way they do it now. But a few things were tried there.
I see. Thank you.
You're welcome.
We have time for 2 short questions, so let's. Okay, one is there.
I have one question about the people only committing to master.
Yeah.
And it's how do you handle when the commit doesn't pass the test? Like if there are 2 teams working at the same repo, so different features. If the other team does, I guess doesn't happen very often, but if it happens, how do you handle this situation?
You're right, it doesn't happen very often, but it does happen. Initially, the pair responsible for breaking the build is going to fix that or try to fix that. If they can't, they pull in other people to fix it. There are other teams I know that do an automatic revert if the build fails. So whatever the latest commit is that fails the build will be automatically reverted by Jenkins, for example, and then they can try again. That's a strategy we didn't use because we want to encourage responsibility. So ideally, you should be able to see the build fail on your machine. If the build fails on the build machine, you probably didn't run all the tests on your own machine, right? So it's a responsibility thing more than anything. But there are choices to be made there.
Okay, thank you.
You're welcome. Okay, so there's one last question. And afterwards, please do come and find me somewhere here, and we'll talk a bunch more about this, because this is a contentious topic, I know.
I have one more question regards how you don't have branches for functions. I'm still a bit confused. Like if the function cannot go live just due to some kind of constraints that, for example, it supports sending data to some kind of updating machines which cannot be deployed partially. So how are you refusing of the branches? How?
By using a feature toggle. The feature toggle is essentially a glorified if statement, and how you implement the feature toggle, that's actually not very relevant. But let's say your feature toggle is set to off, and all that code is within that if statement, right? It would probably be better to implement it as an abstraction rather than an if statement, but still, if it basically the feature toggle switches on or switches off the abstraction. So all your code would be in that abstraction, and then once it's done, and by done I mean available or could be seen by the consumer, then you can flip that feature toggle. And the code will, which was dormant, but in production, will become active in production. The reason the feature toggle is so useful is that you can still test. And you can still deploy in small steps to production and integrate with everybody else continuously, while even the feature may not be seen by people yet. So you effectively decouple deploying, which you should not delay because of the feature not being ready, from releasing, which is a business decision, right? This can only go live from May 1st. That's a feature toggle. And on May 1st, we flip that switch and the code becomes active. This is how Netflix and Facebook and all the other companies that do this on a large scale are successful. If they would use branches, that would slow them down significantly. Okay, I think that's the last of the questions for now, the time that we have. Thank you so much for coming again, and see you somewhere today. Enjoy.